recording minimized so I don't have to look at it, and let me bring up this so that I have something to write on. All right, let's talk about what's rational and what's irrational. The definition of a rational number is it can be written as a fraction. Definition of an irrational number is it cannot be written as a fraction. In other words, irrational numbers are the ones that have the infinite string of numbers to the right of the decimal point that never end, like pi. Pi is irrational. It's approximately equal to this, and like I said, it goes on forever, but there's no fraction that's equal to pi. So it's irrational. Same with E, the number that we were fooling with the other night. E is irrational. And all square roots of numbers that are not perfect squares. In other words, that's rational because I can write it as 2 over 1. That is irrational. If I cannot turn it into a whole perfect number, it's irrational. In other words, all radicals are irrational unless you can convert it to either a whole number or a fraction. If I had 9 over 4, that's actually a rational number. It's equal to 3 over 2. So the square root of 9 over 4 is rational. But in general, these are all irrational. Not in general, absolutely these are all irrational. Notice that I cannot turn any of them into numbers. Square root of 9 is rational because that's 3. That's equal to 3, so that's rational, but all the others are irrational.
So I put an arrow next to the one I selected.
And that's correct, yeah. Excuse me, Darren.
That's you're fine.
A lot of pollen in the air.
Indeed.
All right. So I just want to open up number 2 then, right?
Yeah.
I'm going to make sure I can find these when I try to get back to them. I'm not quite sure where this unzipped it to. Let's see. It looks like it's it's under downloads. Okay, good. I can figure out how to get back to it. Okay. Blow this up a little bit. Can I zoom in? Yeah, good. So we're just looking at the right side, huh? Which graph corresponds to the set of real numbers? Well, what we need is a graph that's got those 4 points on it. Okay? Well, all 4 start with that first point correctly. Correct? Okay. Well, let's see where minus pi is. That looks like minus pi. You can't tell where I'm pointing. Now you can though, right? Okay, that's minus pi. That isn't. So I can cross this one out. Okay, but that is, and that is. So 1, 3, and 4 are possible answers. Now let's look at the next number, 7/4. Well, 7/4, is that 7/4 right there? Not the way they've drawn it, but it is.
No. Okay.
Notice that all 4 of their 7/4 are in the 1 1/2 slot. They meant it to be 1 3/4, which is 7/4 is 1 3/4. So it should be a little closer. Oh, no. It's 1, 2. It's two hash marks per number. So that's not 7/4, that's 5/4. That's 7/4, but that point doesn't work. This is 7/4. So C works for the first three numbers. And it also works for the fourth number. And that's where I was getting screwed up. I was thinking each grid mark was 1. It's not. 2 grid marks are 1. So that's definitely in the 7/4 slot, and so is that one, and so is the bottom one. So now we've got 2 possible answers, C and D. So whichever one has 2.75 as its fourth point, it's clearly not the bottom one. That's over 3. But that one right there is 2 3/4. So that's the answer. The third one.
Okay.
Okay? And I wonder if I can do next. No, it's not going to let me do it that way. I wonder if I can do it this way. No, I'm going to have to close it out and open each one. That's fine. So you said 41 degrees. Well, they want the Fahrenheit given the Celsius. So I don't even have to do much algebra here. I just got to plug in the Celsius, right?
Which is -5, right?
Right. So that's all I'm going to do is plug it in, and then I'm going to simplify and do the math. So that cancels with that, and I've got -9 plus 32. See why it's -9? So 23 is the answer. You added 9 to 32 to get 41, which basically just disregarded the negative sign. In other words, even though the 5's cancel, I still have a -1 here, and that negative sign goes in front of the 9 now. So it's -9 plus 32. Okay? I'm just going to go on to the next unless you
that's fine.
say something. I'm going to assume that you get it. What's the master formula that applies here?
Isn't it dirt?
Dirt, yes. D equals R times T. Okay, so for driver A, travels at a constant speed of 60 miles an hour to the west. So he's going west at 60 miles per hour. Driver A, excuse me. Driver B leaves 3 hours later from the same place and follows driver A at a constant speed of 72 miles an hour. How long does it take him to catch him? Now this problem is not probably as simple as it would appear. It's tempting to take 12 miles per hour times 3 hours. right? Because he starts 3 hours late and he's going 12 miles per hour faster than the other guy. But that really doesn't work in determining these. What we need, all right, we got the distance of driver A. We don't know what that is, but we know his speed is 60. And some time. We don't know what time for driver A is either. So there's our equation for driver A. Driver B is going 72 and takes some time, which we also don't know. What we do know is that the distance each one of them is going to go is going to be the same, right? In other words, at some point, driver B catches up with driver A, meaning they both went the same distance. So I can set these distances as being equal to one another. Now, the other thing that we know is that driver B's time is 3 hours less than driver A's time, right? First of all, here's what we have at this point of our logic. And this is a bit of a logic problem. But I know that dA is equal to dB. In other words, their distances that they travel is the same. So therefore, this has to be true. In other words, the right side of that equation's got to be equal to the right side of that equation. You with me? Problem is, I can't solve that because I got two variables. I got driver A's time and I got driver B's time. That's two different variables. But what do I know? I know that driver B's time is 3 hours less than driver A's time, correct? He started 3 hours later. So the total time that driver B has been driving by the time he catches up to driver A is driver A's time minus 3. So that means I can say that 60 times driver A's time is equal to 72 times driver A's time minus 3. You see what I did? I just substituted. In other words, I know that T sub B is equal to driver A's time minus 3 hours. Because he left 3 hours later. In other words, if driver A drives for 5 hours before they meet up, then driver B has only been driving for 2 hours. Get it?
So that you multiply the 72 by 3, right?
No. So all I'm trying to do is solve for a variable. And now I can do it because I've got only one variable in that equation that I check marked. And that's T sub A. So let me solve for that variable. Let me erase this to give me a little bit of writing space. And I get 60 T sub A equals 72 T sub A minus 216. In other words, by just distributing the 72. Okay, now I put all my A's on the right side, meaning that's 12, T sub A. I put my numbers on the left side because that leaves everything with positive coefficients. And then T sub A is going to be 216 divided by 12. What number is that?
18.
So what's the answer? How many hours would it take driver B to catch up to driver A?
18.
That's the number of hours driver A has traveled. Remember, driver B left 3 hours later, so he's only gone 15 hours.
15.
Right. In other words, if T sub A is 18, then T sub B is 18 minus 3. So the answer is 50. I'm not sure that this is necessary, but it's always helpful if you check. In other words, if somebody said your life depends on this answer, well, let's see. So I'm saying that driver A goes at 60 miles an hour for 18 hours, right?
Mm-hmm.
Well, what is that? That is 1,048. Oh, hold on, 100. What is that number? That's can you do that in your calculator real quick?
What was that?
60 times 18.
1,080.
Okay. So now we'll figure driver B. In other words, that's the distance that driver A traveled, right? Well, driver B is going at 72 miles an hour. He only went 15 hours. Does that equal 1080? And if it does, I'd bet my life we got the 2 right answers.
Yep.
Okay. In other words, if you're taking a test where you have time to check, I would advise doing that when you have a problem like this. I don't know, when you take these tests, are they going to be timed?
Yeah, it's 3 hours.
3 hours, wow. Okay. All at once, right?
Yep.
Let me do this real quick. In other words, the way you solve an inequality is very much like you solve equations. Which side am I going to put the x's on?
Left side.
Well, that's going to leave me with a negative coefficient if I do that. Notice that if I move this x that's on the left to the right side, I'm going to have positive coefficients. And then if I move the number that's on the right to the left, I'm going to have positive coefficients. So I'm going to end up with this as a first step. Just moving the x's to the right and the numbers to the left. And now I'm going to divide both sides by 3. And there's my answer. So it's B, answer B as in boy. Now, when you're dealing with an inequality, whether you have positive or negative coefficients is fairly significant because you have to swap the inequality sign otherwise. By that, I mean, let's do it by moving the x's to the left, okay? Would have given me this. I'm going to move the 4 to the right, would have given me that. Now I got to divide both sides by minus 3, but whenever you divide an inequality by a negative number, you got to turn that sign around. So you got to make sure that that flips directions whenever you multiply or divide by a negative number. Not when you add or subtract, but when you multiply or divide. So you still get the same answer if we'd have done it the other way. It's just, it's a lot easier to make a mistake and forget to switch that sign. Well, I ignored that basically by making sure I didn't have negative coefficients in front of my x. It's the x term that you want to keep your coefficients positive because you know the last step is always dividing by that coefficient. Well, you'd rather it not be negative. I think this one we can just answer. Oh, no, there's lots of graphs. Oh, okay, hold on a second. So,
Yeah, it doesn't.
Is this one it? We'll just go through each graph and see if it fits this equation.
Well, there's only one graph that it didn't.
Well, this one actually looks like it's it. This has a y-intercept at -4, and its slope looks to be, let's see, up 1/2. That's 1/2, a slope of 1/2, rise over run. Now, it's a little dangerous using just, in case this thing is not exactly on the grid mark, but if I go from there, I go up 4, I go over 8. So it's 1/2 no matter how you look at it. So that's the correct answer.
Okay.
You must have realized that, and that's why you didn't take pictures of all the graphs.
That's right.
Okay, good. So how are we going to do slope? We've got 2 points. First of all, generally, what is slope equal to? The words. These are the words you want to memorize forever. Rise over run.
Rise over run.
The reason is that if you can remember rise over run, then you can always figure out what the formula is. Well, what's the rise? The rise is the change in the y-coordinates. The run is the change in the x-coordinates. And the change in the y-coordinates is y sub 2 minus y sub 1. The change in the x-coordinates is x sub 2 minus x sub 1. So what is y sub 2 minus y sub 1? This being y sub 2, the 4.
4 minus 8.
Okay, what's that?
Positive 8.
What's 4 minus a minus 8?
Minus 12.
Do it on your calculator. Now your calculator probably has 2 negative signs on it. One is for subtraction and the other is just a negative sign. But you know, maybe it doesn't. Will your calculator do 4 minus a minus 8?
Well, 4 minus 8 is minus 4, right? So minus 4.
No. Here's what we're doing. 4 minus a minus 8. So what do those 2 minus signs do?
Oh, it's an addition.
Correct. So it's 4 plus 8, 12. That's the rise. What's the run?
The run is 1/2 minus 0.
Okay, so the run is 1/2. Now how do I solve that? What is 12 divided by 1/2? However way you want to do it. It's not 6. 12 divided by 2 is 6. So 12 divided by 1/2 cannot be 6.
It would be 24 then.
Correct. In other words, when you're dividing by a fraction, you flip and multiply. That's the same problem as this. Or if you want to do it on your calculator, you could do 12 divided by 0.5 and it'll give you 24. In other words, your best bet might just be to use your calculator on all these calculations, especially anything funky like negative number. I don't know. Can you do that one on your calculator? It kind of depends on whether you have that minus key on there. I don't think my calculator will let me do that. If I do 4 minus a minus 8, no, it doesn't like that second minus.
All right.
So as long as you can figure out how to do it, it doesn't matter how you do it. You don't have to do it in your head, but you got to be able to do that on a calculator. The easiest way to do that is to write it out and change those two minuses to a plus first, so that you realize you're looking at 4 plus 8.
Mm-hmm.
All right. But this one, let's make it. No, it's not. Okay. Pretty standard traditional problem in algebra is figuring out the equation of a line that goes through 2 points. So let's definitely make sure you know how to do this, because you're going to have to do this. Every algebra test in the world is going to have this kind of a question on it, at least once, maybe more. What's my slope? Look at your 4 answers and tell me what my slope is. That's the easiest way to find the slope, believe it or not.
So
Y equals mx plus b. That's your general format for the equation of a line. M being the slope, b being the y-intercept. Okay, if you look at all those answers, they all have the same slope. What is it?
2.
What coefficient is in front of the x? That's the slope. -1. See why? In other words, I don't write the 1, but I need the negative sign, because it's a negative slope. It's a slope like that. It's not a positive slope like that. So I definitely need the negative sign. I don't need the 1. But the fact is, all 4 of those have a negative in front of the x, which means we don't have to really do the math to figure out the slope like we did on the last problem. I mean, if they'd have put something different in there, we would have had to. But the fact is, they told us the slope is -1 by giving us just those answers. And that is actually useful. That means that now I can write this much of it. Y equals -x plus b. If I can solve for b, I've got the answer, right?
Mm-hmm.
Well, this has to be true for either of those points. So I can solve for b by just taking either of those points and plugging it in for x and y here. So pick a point and tell me what I should write. Use that point right there.
-3 plus 7.
-3 comma 7, that's the x-coordinate, that's the y-coordinate. So plug in the y value for this y down here, plug in the x value for this x, and then we'll be able to solve for b and we'll have our answer. So what should I write?
The 7 equals -3.
Hold on. 7 equals minus a -3. It's real easy to drop negative signs. Everybody does it. People see a bunch of negatives together and they think they can just drop one of them and it's the same thing, but it isn't. If I have a negative, I have 2 negatives, I have a positive. If I only have 1 negative, I got a negative. So it makes all the difference in the world. Okay? So this becomes +3, which means b becomes 4, which makes that the correct answer. In other words, once I solve for b, that's the only difference in these 4 answers, is b. And I could just as easily have picked the other point. Pick the other point and solve for b.
So 5.
Always make sure that you put the y coordinate there, not the x coordinate. You don't want to go left to right. One moment, Karen. Hello? Yeah, hi, Gail. Listen, I'm in the middle of a math tutoring session right now. Can I call you when I'm done tonight? It'll be about 8 o'clock, a little after 8. I'll call you back then. Thank you. Bye-bye. Sorry, I didn't want to miss that call. So if I pick the other point, what am I going to put in here?
-1 equals -5 plus b.
Okay, now if you solve that for b, you also get 4. So I could pick either point because both of those points are on my line. And any point that is on your line has to satisfy this final equation. Whatever equation of a line you come up with, well, every single point on that line is going to satisfy the x and the y. If you plug it in, they'll all be satisfied. So that's the easiest way to do 2 points and to figure out the equation. Now, had they not given us 4 answers that all had the same slope, then our first step would have been to solve for the slope, right? Which would have been -1 minus 7 over 5 minus a -3. Well, that's -8 over +8. That's a slope of -1. So we could have solved for the slope by just doing rise over run. And normally we would have had to. In other words, on most questions, you're going to always, that's the first step, is to solve for the slope. But when they give us 4 answers that all have the same slope number, they make it easy. We don't have to do that stuff. Are you going to have 50 questions that you have to do in 3 hours? Okay. I would say make sure when you take your test you're all set up, have your Wolfram Alpha open, have your calculator there, have pencil and paper there, be all set to, because we already know that you have to use Wolfram Alpha on some of these questions involving numbers like E. All right. Which equation represents attendance in terms of the price per ticket? Well, let me think about this for a second.
So I did 5,000 times.
So 5,000 people, oh no, 500 people. No, hold on a second. So let's see, the total revenue, oops, what happened there? Let me do it this way here. So the total revenue in the first case, I don't know if this is going to be helpful or not, but it's 100 times the number of people. So it's the ticket price times the number of people. In the second case, the revenue is also the ticket price times the number of people, only it's 108 times 45,000. Okay. This number is D, and this number is P. So I've got the revenue equals P times D. Guessing that 108 times 45,000 is probably, what is it? 12.5?
4,860.
How much?
108 times 45,000 is 4,860.
1 million, oh, 4,860.
4,860.
Compared to 5 million in the first case scenario.
$140,000 difference.
Yeah. I don't know, I'm drawing a blank. A total blank on this one. Let me think about it for a second. I don't want to waste your time while I sit here and try to figure it out. What would be better would be to go to the next one, and then next time we meet, I will have figured this one out.
Yeah, let's go to this. Keep going.
Is that fair? Yeah. Because it really isn't fair to you for me to sit here and spend 10 minutes trying to figure it out. So I'll make a note that I need to do number 9. I got a copy of it, so I'll be fine. That's an interesting problem. Gosh, I'm trying to figure out how I'm going to solve it. I'm not sure, but it'll come to me. What I'm amazed at is how much harder that problem was than anything we've looked at so far. It must not be. There must be something real simple about it that I'm just not seeing. Well, anyway. Okay, so which one do you think? You already put the answer down, didn't you?
I think it's number 2 because 5.2% is 0.052. And then,
why isn't it the bottom one?
Well, that's what it was, either the second one or the fourth one.
It's the fourth one. And here's why. Because you're multiplying the 0.052 times his monthly sales, which are X. They're not X plus 1848. Be nice if you could add in your salary to what you're earning commission on, but you can't. That's not the way anybody does it. So, in other words, you're going to earn 5.2% of X, which is this part, plus
the salary.
Your base salary. Yeah.
Okay. All right, next one.
Okay. Okay. Relations don't have to pass the vertical line test. Functions do. So only one of those functions is going to pass a vertical line test. Which ones do not? Let's cross them off as we get to them. Let's start with A. Okay. Now, if you're not sure whether they pass the vertical line test, then draw the points. There's 1, 1. And you don't have to be precise. You just got to have them approximately. There's 5, 2. Here's 8, 2. And here's 9, 3. Does that pass the vertical line test? It does. What would cause it to fail is if I had 2 dots above one another. In other words, I would not be able to have, that would not be a function. I can draw a vertical line through those 2 points. The other way to think about it is that for any given value of x, you can only have one value for y. So this is a function. I've got 4 different values for x, and I've got 4 values for y. Now 2 of them are the same, but I can have 2 dots horizontally. In other words, there's nothing wrong with having 2 dots like that. If I had a dot here, that doesn't cause it to flunk the vertical line test. It just says that when x is 5, it's 2, and when x is 8, it's 2. That's fine. So A is the answer, but before we go on, let's figure out why. Notice why B doesn't work. If I try plotting the points on B, there's 1, 1. But then it says when x is 5, y is 2. And then it says when x is 5, y is also 3. Well, that flunks the vertical line test right there.
Mm-hmm.
So that flunks. This one down here, notice that when x is 1, y is 1, and when x is 1, y is 2. That's a flunker. And this one down here, when x is 8, y is 2, and when x is 8, y is 3. So none of those 3 can be functions. But number 1 can be. Now, it's a little confusing, this part here, because it looks like that causes it to flunk. But it doesn't. That says when x is 5, y is 2, and then when x is 8, y is 2. Well, that doesn't flunk any vertical line test right there. Those 3 points do not flunk the vertical line test. Okay?
Yeah.
You skipped one. 12.
Yeah, no, okay.
All right.
Maybe we should skip these word problems and then you can take a look at them.
I don't need to. We can do the. I know how to do this one. That other word problem is just different. I'm sure that there's an easy solution to it. I just wasn't able to see it. So I don't know that we need to do that. These are actually pretty straightforward. He's got a choice. He can get a CD that returns 2% interest and a money market fund that returns 3% interest. Over the next year, he wants to earn this amount of interest on an investment of $10,000 between the CD and the money market fund.
Mm-hmm.
How much should he put in the CD? Well, all word problems begin with defining your variables. Okay? Well, the best variable to use is x. So I'm going to let x equal the amount to put in the CD. What's the second variable?
Money market.
Well, I could use y for that, but I've got a total of $10,000 to invest, so rather than introduce a second variable, let's leave the whole problem in one variable, x. That's the amount I'm going to put in the money market fund. In other words, if I put x in the CD, everything else goes in the money market fund. 10,000 minus X, right?
Mhm.
Okay. So now we got our variables defined. It's relatively easy to solve. The total interest I'm going to earn is the amount that I put in the CD times 0.02% or 0.02 plus the amount that's going to earn 3%, which is in the money market fund, which is 10,000 minus X. And that is the total interest. That's the interest I'm going to earn, just the interest on the CD, and that's the interest I'm going to earn in the money market fund. And what they said is that that needs to equal $263.50. $263.50. Well, now we have a straightforward equation that only has one variable. And that's why I defined my second variable this way. Had I used y, then I would have needed a second equation, because I would have had two variables and I would have had to come up with a second equation. The second equation would have been x plus y equals 10,000. Okay? So I could have solved it, but it would have been a two-variable problem, and those are going to be harder to solve. As a single variable, what's the next thing I need to do here? Get rid of denominators and parentheses and sometimes exponents. But that's not a bad strategy to use when solving equations. Get rid of denominators, there are none. Get rid of parentheses. How do I get rid of those parentheses over there?
You multiply the...
Yeah, you distribute, it's called distributing the 0.03 to both terms. So what does that become? 0.03 times 10,000 must be 300 minus 0.03x. You see why it's a minus sign?
Mm-hmm.
Okay, that's all equal to 263.50. Now I can combine my x's, and I get negative 0.01x on the right side. I left it on the right side because it's already on the right side. In other words, I know it looks like I'm going against what I said earlier. Put your x's on the side where their coefficient is positive. Well, I can do that. Let's do that. I kind of like it now that I see that. I'm going to take the 0.01x that would have had a negative sign, and I'm going to put it over here with a positive sign. Okay? So now it's plus 0.01x. And now I'm going to take that number and move it to the other side, which gives me $36.50. Now I got nothing but positive coefficients. X has to be $3,650. That's the amount you put into the CD, and you had the right answer. I would have cut short the problem if I didn't know what the answer was, but I didn't, without doing the math. Okay? So these problems are pretty common where it looks like you have two variables, but you can really, the second variable you can define in terms of the first. Especially these problems where you have a certain amount of money that has to be split up into two expenses. Use one variable only on those. I'm glad they asked this problem. You don't need to do a lot of math to solve this. Use the technique called back solving. Okay?
I just did it minus 550, I think.
Don't know if that's right. Probably isn't. I'm guessing that it's not that easy. By back solving, I'm going to assume that 3 is the correct. I'm going to start at the top because I have no idea what the answer is. I'm going to assume 4 is the correct number. Okay? Let's see if that works. If I've got 4 servers, I got to pay them $8.50 an hour, so it's 4 times $8.50. I didn't say how many hours they're going to work.
But it also says how many servers can be scheduled to work on Saturday. That's what kind of threw me.
Well, it's kind of throwing me too. Hold on a second. The restaurant needs 8 people staffed on Saturday night, but can only afford to pay a total of $59 per hour. Okay, for staffing. All right, so if 4 servers is right, then it's 4 times $8.50 plus 4 times $5.50, right? If we're going to have 4 servers, we're going to have 4 bussers. Because all we have to do is figure out, does that come out to be correct? Well, that's $34. That's $22. That's a total of $56. Not correct. We need an answer that's 59.
It's got to be 5 then.
Well, we're just going to keep trying. Oh, yeah, because, very good. It's got to be 5 or 6. It's got to be more, right? In other words, I can afford to actually pay more servers. It's not going to be 3, because that would result in a lower than $59. We already figured out that when it's 4 and 4, it's only $56. So I need more of the expensive guys. So yeah, you're almost certainly right, but let's check. But it could also be 6. We don't know for sure. So it's 5 times 8.5 plus 3 times 5.5. Well, what is that? $42.50, and this is $16.50. Bingo, $59 with 5. Now, notice I didn't set up an equation or anything.
Yeah.
All I did was just check every answer until I got the one.
Yeah.
Only there were other things I was able to use. In other words, when I tried 4 and it came out to be too small, $56, I knew that it had to be greater than 4. There was no point wasting my time trying 3. A lot of times when you're using the technique of back solving, that'll happen. In other words, pick the second lowest number to start with. That's always a good idea because it will tell you whether your answer needs to be higher or lower. Let's say we started with 4 and we got an answer of $60. Now I know what my answer is. It's 3. I don't have to do any more work. Because since 60 was greater than 59, I need fewer servers, not more. And there's only one answer that would be less than 4, and that's 3. So a lot of times that'll help you. It's very rare that when one uses back solving that you have to actually do the math for all 4 numbers. We didn't have to here. We had to do the math for that number. And then we knew it had to be a bigger number, so we didn't even try 3. So we did the math for 4 or for 5 servers, and that worked. So we only had to test 2 options, and that usually is what happens. And frequently, that's by far the easiest way to do the problem. For one thing, when you're done, you know you're right. There's no check step. In other words, if I were to solve this algebraically, let's say that it wasn't multiple choice and I had to solve it algebraically, it'd be much more complicated. It would have taken a while to figure out how to set up the algebra equation. Then I would have had to solve it. And then I would have had to check it to make sure that it came out to be $59. So back solving really was quite a bit quicker than algebraic solution here. Something to keep in mind always is if you can back solve it, try to. Darren, I have a 7 o'clock tonight, so I've got to run a couple minutes over without noticing it.
All right, so I'll circle back with you during the week and we can finish it.
And we got through 13 without doing number 9. Okay, so we'll know where to pick up, and I'll know what to work on in the interim.
All right.
All right.
Hey,
yeah.
I think I owe you for 2 sessions. Is that right?
I have to go through and do my accounting. I don't have it on top of my head. I got too many students, but I have spreadsheets that have everything in it. And I have a record of all your payments made and all your sessions. So it's not hard to figure out. You paid me on PayPal for 3 sessions.
Yeah, which was Friday.
Yeah, I think you've had 2 sessions since then, if I'm not mistaken. But don't hold me to that.
All right, I'll pay for another 2, and then we'll go from there.
Yeah, I'll let you know if there's a mistake there.
All right.
I think that's right, but I'm not positive.
I'll talk to you later.
All right, Darren. Bye-bye.